Okay, just a quick reminder about what we're doing in Chapter 8. This week, it's all about sequences. So the very first day, it was all kinds of sequences. We didn't know what the patterns were going to be. We really had to think outside the box, try something for the rule. If it worked, great. If it didn't, tweak it, change it up somehow. We didn't know what it was going to be on Monday. It was just a pattern. Tuesday, we talked about arithmetic sequences. Something is arithmetic if and only if you're adding or subtracting the same number every time to get your next term. Okay, so those things are going to be classified as arithmetic. Today we're going to talk about geometric sequences. And geometric sequence is a sequence where the ratio between your consecutive terms is constant. What does a ratio look like in math? A fraction. Okay, so it's like one term divided by another term. That ratio is always the same. Okay, so that means that we are multiplying or dividing by the same number every time. So I think on your quiz tomorrow there will be a set of questions where it will give you a sequence and it'll say, is it arithmetic, geometric, or neither? And I usually test first for arithmetic. Am I adding or subtracting the same thing every time? Do I have a common difference? If I have a common difference, then it's arithmetic. If it doesn't have a common difference, then I check ratios. Am I multiplying or dividing by the same thing every time? If I am multiplying or dividing by the same thing every time, then it is geometric. And if I'm not adding or subtracting the same thing every time, if I'm not multiplying or dividing the same thing every time, then I just answer neither. Could it still be a sequence? Yeah, it could still have some kind of pattern. It just isn't arithmetic or geometric. So always remember about Monday, there's this larger outside of the box patterns. And then on Tuesday and today, we're just putting them in tiny little boxes. These are the ones where you add and subtract the same thing. These are the ones where you multiply and divide by the same thing. Now, one quick thing to talk about with ratio is we're really going to focus on multiply because division is multiplication. Right? If you're dividing by 2, you're multiplying by 1/2. So we're going to treat all of these like multiply by the same thing. Might it be a fraction? Yes. Okay. When you're trying to get this ratio, okay, you want to do the later term divided by the previous term. Okay, so it's kind of like when you're trying, if you're having a hard time seeing what the ratio is, sometimes the ratio will be really easy to spot, but sometimes it might be harder for you to see what the ratio is. Make sure you're doing the later term divided by the previous term. In sequence notation, that would be a sub n divided by a sub n minus 1, the one right before it. So like I could do a sub 5 divided by a sub 4, or a sub 4 divided by a sub 3. It's just whatever n is, the denominator is going to be 1 less than that. Okay, a sub 3 divided by a sub 2, so on and so on. And if it's geometric, these things are always equal. Yeah, Aiden. Well, you could do the previous term over the later term and it would be the same, but that's not your actual ratio. Like, that's not what you multiply to get to the next term. So to get the right ratio for writing a rule, it really should be previous divided by, later divided by previous. Okay, and so that kind of leads us down here into this. We're going to call that the common ratio. Like I said, sometimes you don't have to do all that work because you're like, oh, duh, I'm multiplying by 5 every time. Okay, that's easy to see. If it's a fraction, it might be harder for you to see, so do later term divided by previous term. And let's look at this example. Okay, we're going to call common ratio R instead of D for common difference. That's the arithmetic only. Here's our example. 1, 2, 4, 8. Geometric? Yeah, what's your common ratio? 2. So we would say here it's geometric. It's R is equal to 2. You can see that this one's easy. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. Okay. You're also looking at it as the later term 8 divided by the previous term. So 8 divided by 4 is 2. 4 divided by 2 is 2. 2 divided by 1 is 2. They're all equal to 2, right? Those ratios. I'm going to give you, before I tell you what the formula is, on the next slide, I'm going to give you and your pod members a moment to try to come up with a rule. Maybe we did this already on Monday before I gave you any rules or formulas. So can you write a rule in terms of n that will give us any term of that sequence that we want? So it's going to be a sub n equals. Go ahead and chat with your group members.
You just.
But then might be like n divided by like the no
And then the first one is 2. It's 2 to the power of 2.
Yeah. So then, of course, it's not going to be just like arithmetic, right? So you're going to have to think about
So our first term is 2 to
and
0.
change
Yeah.
the formula.
1. My bad.
Arithmetic almost.
And then you would.
Well,
Confusing
you are
me.
multiplying. So I go with that. You're multiplying repeatedly by R.
Add 1.
So you
You guys got it? So I try to say I know Now look around at your check your answers. You don't all have the same answers. You don't all have the same rules. Check your rules and see if it really works. So try subbing in ends 1, 2, 3, and 4 and see if they know those things. You just need to tweak it a little. What's your kind of idea?
Okay, you know what R is?
Yes, correct.
R to the
2
power of
times
n
2 to the
is
power of
gonna
1.
be, but I don't,
it's
gonna be like your answer. Like after the second, it's gonna be something of then like a subtraction add in there somewhere.
Okay, yes. So you guys, so there is a power.
Yeah.
See if you can figure out where the
Oh, wait, and then it's like.
other piece comes in. You can keep that.
Ow. Start off.
Thought we did and then we figured out.
Right, but this is start off. Plus something. So it's gonna be like plus or whatever A is.
Oh,
We get it on our
Shower girl. Yeah, pretty sure it's got
okay, so when you do
We'll say like
and
it's like
that looks a lot like arithmetic.
saying now and
So
then.
his rule for exam starts up at 5.
Today's the week I'm holding you accountable, okay? Wait, how do you, not this,
No.
how do you?
You're not adding.
There's G.
You gotta figure out how to say it.
It's gonna be like
They have 1 times R.
sheets.
You guys got ideas?
I just laughed at you.
That's my guess. Can somebody check that? Okay, so it'll be 1/2.
Do you know why you chose?
We'll all start laughing.
That's my guess. Does that make sense?
And R is.
A to the power of 0 times. Wait, no, A 0. Does not work? No?
It works for.
Okay, so you kind of figured out.
It doesn't?
So it will matter where your one is in the. Well, does it work? Test it.
No, you're right. Wait.
1 times 1.
No, that doesn't make sense.
See, you just like that works. Hold on. Okay, 2. Yeah.
N R to the power?
That's what I meant.
Why were you?
Yeah.
And
then,
then,
like, if we did, like,
we thought about
so, like,
squares.
there, it'd be like 2. If you're jumping by pace, it'd be like 2, and then if you do the second turn, 2 minus 1 would be 1. The second turn.
This pattern.
I think it's R
You
and then
said,
times
you
two.
said
How
it's
many
the opposite.
that's my that's not right.
Yeah, that's why we thought it
Starts with
might be
shape.
because then it's just.
Well, what is that?
Yeah, and I didn't know. I was trying to think of the word that.
That's the one that's
Another freak If we don't understand it, neither do we make a score.
That's what you think.
They actually,
You know that goes in my house. I don't need to know.
There's two factors. No, Kelsey.
Okay, let's come together. I had some good conversations around the room. Remember, you have a quiz tomorrow, so like, don't just shut down in sequences. You gotta be in it and thinking and coming up with some things. I always want to reiterate, there's more than one way to come up with the rule. I'm going to give you a rule on the next slide, but you have been doing patterns since you were in kindergarten. So you know about patterns, and you can come up with some rules. Like, yeah, the math part is hard, I know, but you have options, so don't be afraid to try them, okay? Okay, what I am hoping you would notice in this pattern is that when you're trying to get to the next term, you are repeatedly multiplying by 2. Okay, and so we had talked about this when we did arithmetic sequences and we saw we were doing like plus 4, plus 4, plus 4, plus 4. And I said, what do you think a rule might be? Just blurt it out. And a lot of people in the arithmetic sequences said n plus 4, right? And then we tested it and it didn't work. So a lot of times in geometric, when you see times 2, times 2, times 2, times 2, you might instantly think n times 2, but we know that that's actually arithmetics. We had talked about that previously. So you might think initially about something like, okay, I keep multiplying by 2, so let me do 2 times n. That's still a good train of thought to go with. But what you're going to find is if you're checking, like, a sub 1, that's 2. And then, like, if you tweaked it, you did, like, minus 1. Okay? Then when you check a sub 2, you'll get, what? 4 minus 1, which is 3. So this is 1, this is 3. And if I did a sub 3, that's 6 minus 1, so that's 5. And this one's coming out to be arithmetic, but we already knew that because we did arithmetic. Okay, so that's 2n is not going to give us what we want. That's going to be like linear. That's a slope. That's constant slope. That's adding and subtracting the same thing every time. So you got to reframe your brain here. What does it look like mathematically when you do 2 times 2 times 2 times 2 times 2 times 2 times 2? It looks like a power. It's repeated multiplication. So repeated addition is multiplication. Repeated multiplication is a power. So we're going to write, most groups did, 2 to the n. At least that's where you start, right? 2 to the n. So we're just like thinking about, okay, if we were doing this on our own, we could still come up with a rule. We're not helpless. We have options. Okay. So then you might start checking it. A sub 1 equals 2 to the first. That's 2. Boom.
Could be 2 to the n minus 1
Okay. You mean minus 1
in the exponent.
in the exponent. So then a sub 1 is 2 to the 1 minus 1, which is 2 to the 0, which is 1. And a sub 2 is 2 to the 2 minus 1, which is 2 to the first, which is 2. And I'm going to jump down and do that fourth one over there. A sub 4, it should come out to be 8. 2 to the 4 minus 1 is 2 cubed, which is 8. Sure enough, I think I got that rule. Right? Now, make sure that you have in your notes that the minus 1 is up in the exponent. If you put minus 1 down on the regular line text, you don't get the same numbers over here. Did any groups have a different version of that same rule? Most people, I think, had that, but anybody have a different version?
I just added a to the first, like multiplied by a to the first,
And why did you do that?
because say that the a1 was a different number, like 5, then it would like completely change the whole thing.
Oh, okay. So let's make a brand new sequence. 5, 10, 20, 40, 80. Am I following that same pattern? Times 2, times 2, times 2, times 2. Okay. So r is equal to 2. And then you would say, okay, 2 to the n. And you would figure 2 to the n minus 1. But that's going to keep giving me these numbers. Remember that you started with 5. So it's really 5 times those. 2 to the n minus 1. So you get 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 8, okay, so on and so on. Okay, so yeah, this is your a sub 1. This is your r, and then it's going to be raised to the n minus 1. A lot of groups, as I was walking around the room, they didn't have the 1 in front, but this could really be written as a sub n equals 1 times 2 to the n minus 1. It's going to be the same thing because anything times 1 is just itself. But there's your a sub 1 and your r. So yeah, you guys got it. That's the formula for a geometric sequence. Write this down. Now, what gets really hard in sequences is after this arithmetic and geometric stuff, and I provide you with formulas, a lot of people sort of shut down anytime they have something that's not arithmetic and geometric. That is not an option for you on your quiz tomorrow. You still have to think outside the box and come up with a way to write the rule if it's not arithmetic and geometric. You did it on day 1. You can do it. I'm not going to give you one that's too hard to write. All of my math students are capable of writing a mathematical expression that will equal those patterns. Okay? I'm giving you the knowledge you need. Or you came here with it. Okay, so every geometric sequence is a sub 1 times r to the n minus 1. Okay. Think about that in terms of your geometric sequence. Suppose you have some term a sub 1. Okay. Then to get your second term, you would take a sub 1 times r. To get your next term, you would do a sub 1 times r squared. To get the next term, you would do a sub 1 times r cubed, because each time you're just multiplying by an r, right? So this is my first term, this is my second term, this is my third term, this is my fourth term. And notice for each of those, the numbered term that you're finding, you have one less r that you had multiplied by, because you already had your first term. You don't multiply by an r for that one. So the fourth term gets multiplied by r to the third, the second term, or the third term gets multiplied by r to the second, this one's r to the first. What is the exponent for your r here? 0. Okay, so this is r to the 0. So intuitively that makes sense to us why this is a sub 1 times r to the n minus 1 instead of r to the n. Okay. Now you and your pod members have a chat. Is it geometric? And can you say why or why not? Okay, let's come together and see what we say. First one, geometric? No. Can anyone kind of offer up their group's explanation for why that's a no? Elise? Okay, you might see it as like a change in signs, right? So like alternating signs, positive, negative. And then when you look at just like the absolute values of the numbers, you're not multiplying by the same thing every time, you're adding the same thing every time. So this is more like arithmetic, but of course because of the alternating signs, we talked about this on Monday, we would have that like -1 to the n or -1 to the n plus 1 to help us out. Okay. Some people I heard talking about like calculating the ratios, so they did like -8 divided by 4, that's -2. 12 divided by -8 is not -2. If I reduce that, it's like -3/2. But the minute you see it's not -2, you can say no, right? Or some people might think about it like, to get from 4 to -8, I did times -2. Did I do -8 times -2? No, this would have been positive 16. So then it's not geometric. There's a lot of ways for you to think about that to get the correct answer there. What about the second one? Geometric? No? Why not? Ratios aren't the same. Okay. If you check your ratio, 9 divided by 3, that's 3. And then you check your ratio, -27 divided by 9 is -3. Not the same thing. Don't be fooled if they're just opposites. That's not the same ratio. Okay. Or some people might do like I did previously, multiply by 3, but if I multiply by 3 again, it would be positive 27, not negative 77. So they don't have a common ratio. Okay. Excellent. Okay. See if you and your group members can write a rule for this sequence and then find a sub 8.
1 by 0.4. I'm working on it. I'm gonna have to do it one of them. And I know I won't finish I'll just do
7.
Oh.
Don't worry.
Okay, we're going to come together. Some people are making their final calculations here. Think about tomorrow on the quiz. When you have sequences all mixed together, you'll have to approach this problem first by saying, is it arithmetic? Is it geometric? Or is it neither? So I kind of have to think outside the box about how I'm going to write my rule. Well, I can see it's not arithmetic, right? I subtract 3 on the first one and then I don't subtract 3 again. To test if it's geometric, this is where knowing that you take your later divided by your previous might be helpful because it's a little bit harder to see what you're multiplying by. Okay? So if you're checking for geometric, check those ratios. It would be 2 divided by 5, 0.8 divided by 2, 0.32 divided by 0.8, and all of those came out to equal the same thing, right? So they are 0.4. Now, I'm guessing a lot of people just assumed it was geometric because we're doing geometric sequences. So we might not have checked all of them, but if you're thinking about your quiz tomorrow, you won't know what type of sequences it is. So you'll have to test. Okay. So it is geometric. R is equal to, you can say 2/5 or you can do 0.4. Either one is fine. I know a lot of groups were using 2/5. And then A sub 1 is 5. That's nice. It's in the list, right? And if you're thinking about the rule that I gave you, A sub n equals A sub 1 times R to the n minus 1, that's all you need. So your rule is A sub n equals 5 times 2/5, or you can put in 0.4 if you want, to the n minus 1. Okay. Your rule should always have n's in it. So that I could then give this rule to Dylan and say, find me the 5th term, and I could give it to Luke and say, find me the 10th term, and I can give it to Chloe and say, find me the 12th term. Okay, they can plug in their own n's. And now you're going to find A sub 8. So that's 5 times 2/5. I usually just do the subtraction in my head. 8 minus 1 is going to be 7. And then this one I think comes out to be a decimal, 0.008192. Now you could round to 0.0082, something like that, but it is a terminating decimal, and so I'm like, I'll give the exact term of the sequence. I'll just write all the digits there for you. Now think about this with geometric sequences, just so you're not alarmed on quizzes and tests. When you multiply by the same thing every time, these things are likely to happen. Your number will get really, really big or really, really small. It just depends on the ratio, right? If the ratio is bigger than 1, if we multiply by 2 6 times, we're already multiplying by 128. But so if the ratio is anything bigger than 2, it goes fast. And then if you're multiplying, like taking half of something, it's going to get into some fractions pretty fast. Okay, so don't be alarmed if you see large or small numbers. Okay, decimals and fractions. Anybody got any questions about that example? You guys are doing a great job. You got 2 more problems I want you to work on your own, and then we'll talk about them. Okay, I'm going to give you both of them at the same time. So on the left, write a rule for that sequence. On the right, write a rule for that sequence. One of them should be fast. One of them you'll have to kind of problem solve. So go for it.
Well, yesterday it was addition.
I'm going to put up a small, like, one way to think about it. It's not the only way to think about it. So if you're on a roll and you think you got something, that's fine. For the second one, you know, these are just 2 terms in the sequence, right? So I know one term in the sequence is 12, and another term in the sequence is negative 96 later on, right? And this was the 15th term. And this was the 18th term. So what would be in between those terms? 16, 17 term. Okay. And there'd be all the terms before, right? Okay. So you might think about it like that. I think we maybe looked at that originally with arithmetic sequences. Like we thought about them as terms in a place in the order of the sequence. So if that sparks any ideas, go ahead and chat with your pods. Throw out ideas. See if you agree or disagree.
So you need to.
Yeah, but there's four Well, sometimes they go two, they go 24.
Well, if you had negative 24.
That's the best thing. Crack that code.
You can reverse it. What day is it?
You're doing this negative 8 numbers. It's 10.
That's for the other two.
Oh, okay. Oh, yeah, there's two problems. Yesterday I wasn't clear about that. Because they can't. You get the benefit of my knowledge. Oh, wait, hold on.
Yeah.
You're just mad that I have khaki shorts.
Is that right?
So
I like this way of making it 8. Can you tell me how you've been structuring it?
Prior plans.
Because negative 8 is like, if I just multiplied one time, right? 12 can figure out with either you get 1.2 by dividing? Yeah. Okay, so think about on this one, you did multiply one time, right? And that would have been negative 8. But how many times did you really multiply? You multiplied 3 times, and then it was like multiplying by negative 8. So that's gonna be 5. Yeah.
No, I just did it. You did it on.
Positive, negative, positive, negative. Negative. Yeah, I don't remember. Is that the fraction version of it?
No, that's.
I think I wrote mine yesterday. in fraction,
There you go.
Let's go get some big
So it's 17.
Okay,
Oh, shoot.
Because they want.
let's come together and chat. We'll start with the one on the left. If I give you a first term and a ratio, can you write a rule?
Yes.
Yes, that is very easy, right? I actually really love geometric sequences if I have the information that I need. It's just 4 times 10 to the n minus 1. Now, you can imagine this one, as we go out, if we're multiplying by 10, these are going to get big really fast, right? Every time we multiply by 10, we'll add a 0 to our number. Okay. All right. On the other one, let's talk about, we know it's geometric, right? I'm telling you up here it's geometric. So we know what special about a geometric sequence? It has what? A common ratio, right? If I give you two terms like this, we did one example like this in our notes on Tuesday. If I give you two terms, just random terms of the sequence, and I tell you it's arithmetic, then you know it has a common difference. If I give you two terms and it's geometric, you know it has a common ratio. So one way to approach this is, can you start by finding R? Because you know there's a common ratio, so there's got to be some kind of pattern here in between these two terms. So do any groups have any like strategies for finding R that they could describe to us? Yes, Luke.
Well, you can divide the terms by each other.
So you're saying do negative 96
Yeah.
divided by 12, which is
-8.
negative 8. And remember, like I'm doing it negative 96 divided by 12 because I would take a later term divided by a previous term, right, to do ratios. Okay. Is that my ratio?
No.
Oh.
And then however many terms are in between them. So for this one, there's 3 between A15 and A18. You do that root of your.
Okay, so let's think about this. If you know you knew the 15th term was 12, and let's say you were just going to the next term, and you knew what the common ratio was, wouldn't you multiply it by R? And then let's say we knew what the 16th term was, so we wanted the 17th term, wouldn't we multiply it by R? And then to get to the 18th term, which we do know is negative 96, wouldn't we multiply that by R again? So we would be multiplying, from the 15th to the 18th term, there's 3 terms in between. So we're multiplying by R 3 times. So we could really write R times R times R as R cubed. And we know that R times R times R is the one big thing we multiplied by, right? Negative 96 divided by 12 or negative 98. And so I like for some of us, like not knowing exactly what to do, the way we set it up right there, and then Luke said, however many terms there are in between, take that root. So if you multiplied by R 5 times, take the 5th root. If you multiplied by R 10 times in between the two terms I gave you, take the 10th root. Okay? So we're going to take the cube root of both sides. Now, if it's odd, we have no issues with taking odd roots of negative numbers, right? It keeps the sign of the radicand, so this is going to be R equals negative 2. Now, there's other ways for you to come up with and solve for R, but that's probably a method that a lot of people like. It's similar to what you did previously with arithmetic, but instead of dividing the two numbers like a ratio, we just found the difference between the two terms, and then we divided by how many terms we jumped. Now we're going to find the ratio of the two terms. We're not going to divide it by 3 because that would be like adding it that many times. We're going to take that root. So we're going to do the cube root. Okay, so if I know that R is 2, does anybody have any ideas for how I'm going to get the rest of my sequence? R is negative 2. I'll say there's a long way to do it.
Just divide by negative.
Start at 12. Divide by negative 2, that's 14. Divide by negative 2, that's 13. Divide by negative 2, that's 12. Divide by negative 2, that's 11 term. That's a lot of like keeping track, right? But I mean, it's a valid method.
If we do what you did for like the 96 and like count like 11 spaces back, and like times that by like negative 2, like the number of spaces times. Like just do it all at once instead of just.
Oh, I know what he's asking. So it's like,
Oh.
so you go back 14 roots. So you multiply negative, so you do negative 2 to the 14th, and then you divide by that.
Are you talking about this one? And Mason
Yeah.
was talking about.
I think you saw the 12, like,
Also,
A,
like,
A sub 15 equals 12, so then you
Well,
go back
because we need to
11.
find a sub 1 to be able to write the formula.
Okay. I think you guys are on to something. I think you want to remember, like, we don't want to go back 11 because this isn't the 12th term.
Yeah, I think
So that's
what
where
you-
Luke
I
is
think
saying
that's
go
what
back
He was thinking with base.
the 14th. Yeah, but Mason's not paying attention to me.
I did find a sub 1. I did 12 divided by negative 2 to the 14th.
Okay, so that you're all kind of saying the same thing. Okay, I like it. Okay, so you could do it individually, right? Divide by negative 2, divide by negative 2, divide by negative 2, keep track of it, right? You open to yourself up to like getting lost in that division, okay? So what some other people are saying is, well, think about it kind of like we thought about this, like how many times did we multiply by r? Remember, way over here is a sub 1, right? And we want to know what a sub 1 is. We're going to have to take a sub 1, not equals, times our r, negative 2. How many times to get to the 15th term? 14, right? Because you always raise it to 1 less than the term that you are finding. So 15 minus 1 will be 14. And when you take a sub 1 times negative 2 to the 14th, you should get the number that is that term, which is 12. So we know that's equal to 12, and then algebraically, if I'm thinking about that, I'm solving, I would divide by negative 2 to the 14th. Now, notice when I have a negative ratio, I'm always going to protect my negative ratio in a geometric sequence with a parentheses, because if you don't protect it with a parenthesis in your calculator is going to give you a negative answer, and a sub 1 is actually positive because you're raising the negative 2 to an even value. So I'm sure negative 2 to the 14th is a really big number. I'm just going to type into my calculator 12 divided by, and I'm going to do negative 2 to the 14th. I get something scientific notation, 7.3 times 10 to the negative 4. You can certainly write that as a decimal, but I'm going to go ahead and change mine to a fraction, which is 3 over 4,096. And then now I have a sub 1, and I have r, so a sub n is 3 over 4,096 times negative 2 to the n minus 1. Or in decimal form, it's like 0.000732 times negative 2 to the n minus 1, something like that. Is that what you got when you divided by negative 2 14 times?
Yep.
Yeah, okay. See, it works. See ya. Okay, it works that way, but that's a little bit longer. This may be a little bit faster.
Very much.
Okay, I also want to point out one other thing. Right up here.
I quit.
Stop.
No, my calculator gave me
Oh,
a different answer.
Okay, well then show it to me later and I will look at it. You probably have an input error. Right here, where we were like thinking about it, like, okay, what if we backtrack to the first term that was 14 R's? What you are also doing right here, you know my formula is a sub n equals a sub 1 times r to the n minus 1. You're just substituting into that formula as well. So if you're having trouble like saying like how many times you did r to go back to the first term, 12 is a sub n, right? That's the term of the sequence. When the term of the sequence is 12, n is 15. So you would put 15 in for n right here, which would give you an exponent of 14. And we already found R, so we could put in the -2, and the only thing that was missing was a sub 1. So essentially, you're like solving a system of equations, but you already know what R is. So then you write a new equation. Okay? And you could do that with the other term, a sub 18 equals -96. Okay, but this would be your final answer, one of these. Okay, what I want you to do right now is work on your homework assignment. We have an activity that we'll do after we have some work time on our homework assignment. So it's like 2:30 right now, probably work at least until 2:50. We'll kind of see how we're doing. So we'll get about 20 minutes. You might get your homework done. Okay. And you can bring me your calculator if your calculator is giving you bad answers. Again, you like